Greetings to all. In today's session, we are going to discuss about intermediate chemistry, which is plus 2 level chemistry we are going to discuss. This is a perspective regarding international level, any entrance or competitive examinations, and national level JEE Advanced, JEE Mains, NEET chemistry, in Telangana and Andhra Pradesh EAMCET examination entrance. Along with that, any competitive exams you are aspiring for, this content will be very much helpful. And this is the content collected from the previous year question papers, and the detailed explanation is provided over here. Let's go with the question number 1. This is the question which is having collection of multiple questions in this, where the structure of 6 substances containing carbons are shown below. 6 carbon containing compounds are provided to us. From these 6 carbon compounds, few questions are given, right? Let's go with compound A is called carbon dioxide, and compound B is called calcium carbonate. Compound C is called ethane with the 2 carbons and 6 hydrogens. D is the hexagonal layered arrangement containing graphite. It is allotrope of carbon. And E is the unsaturated hydrocarbon, where you can find carbon-carbon double bond, alkene, that is ethene. F is the zinc carbonate. So these many 6 compounds are provided, purely made up of carbon. And let's go with the questions which related with all 6 carbon compounds. The first question is, dash is an element. Among these 6 compounds, which is element we have to identify? Carbon dioxide is made up of carbon and oxygen. This is the example of compound. Calcium carbonate is the ionic compound where calcium cation and carbonate anions are present. When you go with the option number C, where you can find carbon hydrogen, it is the compound of hydrogen and carbon. There is alkane. And if you observe the option number D, it is purely made up of carbon and extended hexagonal corners will be there. So it is the pure compound made up of carbon element. It is the best example for the element. So for the question number 1, elemental compound is graphite. Layered arrangement, graphite is the simplest example. Let's go with option number 2. Sorry, question number 2. Dash is a saturated hydrocarbon. We have to read the question carefully before going to answer, because saturated is one condition, hydrocarbon is another condition. Saturation means if any compound made up of single bonds or sigma bonds called saturated. Pi bonds containing compounds are called unsaturated. That may be either double bonded or triple bonded. If you observe carbon dioxide, you can find the carbon oxygen double bond over here, so that it is unsaturated. Calcium carbonate also pertaining double bonds over there. And compound number C is purely made up of carbon hydrogen, carbon carbon single bonds, so that it is the simplest example for hydrocarbon with the saturated covalent bonds. Option number C will be the right answer. Let's move on to option number D. Here also, if you observe, all the carbons join together with the carbon-carbon single bonds only. But it is not the example of hydrocarbon. Within the question they mentioned saturated hydrocarbon. The right answer will be option number C. That is ethane. Let's go with the question number 3. Dash is added to the blast furnace to help in the extraction of iron. Iron is extracted from different ores. The best example for the iron ore is hematite, and the iron oxide form is most suitable for the extraction. During the extraction, what compound will be added in the blast furnace is the calcium carbonate. Option number B will be the right answer for question number 3. During the extraction of iron in the blast furnace, the compound added will be calcium carbonate. Dash has the joint covalent structure. Covalent is nothing but sharing of electrons are possible, and joint covalent in the sense that will be extended further. If you observe the graphite, it is a layered hexagonal geometry. All the corners of hexagon got occupied with the carbon atoms, and we can extend these kind of hexagons further, so that it is the joint covalent molecule. Option number D is the right answer for question number 4. Joint covalent structure. Then dash is the product of respiration. Respiration is the general process of living organisms through which we can inhale the oxygen and exhale the carbon dioxide. Inhalation of oxygen will help for carrying That oxygen will be carried to each and every tissue and cells of the living organism so that metabolism process will be accelerated. That's the reason why oxygen circulation is very important, carried by the process of respiration, and oxygenated blood will be pumped by heart throughout the organs in the human or any living organism by the process of circulatory system, so that inhalation of oxygen and exhalation of carbon dioxide is possible. So respiration product is carbon dioxide. This is generated within the living organisms will be sent out by the process of exhalation in the respiration, right? The product of respiration is carbon dioxide. Dash contains the metal ion with the 20 protons. Here, compound 1 is not having any metal over here. Compound B, you can observe calcium carbonate. Calcium is accompanied by atomic number 20. So that 20 protons are present at its core. So that the right answer will be option number B. If you observe compound C, you can't find any metal here. Option D is also having purely carbons, no metal. And option E is also carbonate hydrogens, no metal. If you see the option number F, where zinc and carbonate, zinc is the metal with the 30 atomic number, so the 30 protons resided at its core. So that right answer will be option number B. Calcium is the best example containing 20 protons in its nucleus. Right? So these are the answers provided, what we discussed just now. So this will be the question number 1. Let's go with the question number 2. The product of respiration is provided. Examples of the carbon compounds are given to you. Carbon dioxide is the example of carbon compound. DNA is also made up of double helical structure. It is the most important property of the genetic matter of each and every living organism is made up of triplets of their genetic codes. And this is also made up of purines and pyrimidites made up of carbon only. And methane is another compound of hydrocarbon. It is the simplest hydrocarbon we can see, where carbon is the important molecule over here. Benzene, another important aromatic hydrocarbon related with the carbon, and finds much more applications in the sensitive organic chemistry. And this is another compound called ethanol. These are the pure examples comes under the carbon containing compounds. Let's move on to the question number 2. A small piece of sodium is added to some ethanol. The temperature was measured before and after the sodium was added. So here the experiment is going to be done. A beaker was taken. In this, it is filled with the liquid called ethanol. Ethanol is a hydroxy compound where thermometer is inserted in order to measure the temperature. Initially, ethanol is accompanied by 19 degrees centigrade. So that piece of a metal piece is added with the forceps. So when this piece of metal, sodium metal, is added into this ethanol, the final temperature is raised with the 29 degrees centigrade. Before the addition of sodium metal, ethanol temperature is 19. After the addition of that piece of sodium with the forceps, its temperature rises to 29 degrees centigrade. Right. Explain how this experiment shows the reaction is exothermic. How can we say reaction is exothermic? Because before going to explain about the concept, first we have to know what is meant by exothermic reaction. Exothermic reaction stands for any reaction is accompanied by rise in its any reaction which is accompanied by rise in its energy during the product formation, which gives out the energy, during the chemical reaction, that is called the exothermic reaction. If you observe, initial temperature will be taken as a 19. After the addition of the sodium metal, its a temperature got rise, so that heat evolved outside. So heat is given up, so that we can say it is the example of exothermic reaction. The reaction carried over here, ethanol, and it is in contact with metallic sodium, involved in the formation of sodium ethoxide. Sodium ethoxide will be formed and followed by release of hydrogen gas is possible. where sodium will be turned into Na plus. During the process, it will be undergone with the oxidation, where at hydrogen H plus now turned into hydrogen gas, molecular hydrogen gas was formed, so that it will be involved in production process. Here you can find the sodium ethoxide. So this will be recorded as a strong base, and hydrogen will be evolved during this process. It is said to be exothermic reaction. If you observe this, exothermic reaction will be there. Heat released during the reaction. You can observe the bubbles are released over here. These are bubbles corresponding to the gaseous hydrogen. Right. How can we justify this is exothermic means? Whenever ethanol is added with the sodium metal, formation of sodium ethoxide and hydrogen, along with this large amount of heat is evolved, that will be clearly identified by rising the temperature of the liquid thermometer to 20 and finally turned into 29 degrees, so that we can say this exothermic. So rise in the temperature is called exothermic reaction. Right. The question number 3 is, for the given close packed structure of the salt made up of cation X and anion Y shown below, ions of only one phase are shown for clarity. The packing fraction is approximately, right? So here, close packed structure is provided where cations are regarded as X and anions are denoted with the Y, shown that ions are only one phase ions are shown to us. The packing fraction should be calculated for this. And moreover, within the problem only, they mentioned the formula for the packing fraction. Packing fraction is equal to packing efficiency by 100. Let's go with how to solve this problem. Right. Here is the closed packed system provided. One phase is provided to you. X is the cation and Y is the anion set to you. And the packing fraction to be calculated. In order to calculate the packing fraction, we have the formula. Packing fraction is equal to 3 into 4 by 3 pi r cube plus 1 into 4 by 3 pi r cube minus. Here r plus and r minus is taken here, right? Okay. So here 3 into 4 by 3 pi r plus cube plus 1 into 4 by 3 pi r minus cube. Okay. So here from these terms we can take some common terms. Common terms taken over here. 4 by 3 pi, 4 by 3 pi is the common term. So that we can take that out. 1 into 4 by 3 pi if we are taking as a common term, and the remaining left will be 3 into r plus by r minus whole cube. 3 into r plus by r minus whole cube plus 1. Here plus 1 will be there, plus 1. In the denominator a cube will be there, that is taken as a by r minus cube. Okay, here another relation is with you, that is 2r minus is equal to a, right? So the value is 2r minus is equal to a. So then from this we can draw the known relation, that is r minus by a is equal to 2. A by r minus is equal to 2. A by r minus cube value is there with you. So that a by r minus is equal to 2, just a substitute over here. And another known term is with you, that is r plus by r minus. R plus by r minus is equal to 0.414. Okay, that is also known value. R plus by r minus, radius. R denotes what? Radius. So that is given as 0.414. That value is not provided within the problem. So this is also known term, and this is also known term. These are the constant values. A by r minus, r plus and r minus are known terms to you. This ratio and this ratio provided, so that we can substitute all known terms over here. 4 by 3 and the pi value is known, that is already calculated one, 3.14. 3 and this r plus r minus ratio value is 0.414, and it is taken as a cubical value, plus 1. Then a by r minus cube value is given as 2. 2 cube can be taken, it denotes packing fraction. So if you substitute all these values, that is exactly is equal to 0.634. 0.63 is provided in the option number B. In order to solve this, first of all, we have to go with the formula. Packing fraction is equal to 3 into 4 by 3 pi r cube plus 1 into 4 by 3 pi r cube minus. So in this pi value is known, r plus r minus if you are taking common terms, so that it will be taken as a ratio. And so if this ratio was taken, how can we take the ratio? Because numerator and the denominator is divided with r minus. Then only it is possible to get like this. What we have to do here is numerator values and the denominator values are divided with the r minus cube. Okay, so that it will become r plus r minus cube. Here it will become r plus r minus cube. And here r minus cube by r minus cube, they get cancelled out. At the bottom we have a cube by r minus cube. Okay, so this is the way to solve the problem. So, but in this problem we have to know a by r minus is equal to 2. R plus r minus ratio is given by 0.414. If you know these two terms, it is obvious to calculate the packing fraction of given closed packing system, right? So option number B is the correct answer for question number 3. Let's go with the question number 4. The calculated spin-only magnetic moment of chromium NH3 taken 6 plus 3, copper F6 minus 3 in Bohr magnetons respectively are atomic numbers of chromium and copper 24, 29 respectively. Okay, it's a question purely given from the coordination for coordination chemistry, where chromium and copper are the peculiar metals because these are having some exceptional electronic configuration apart from the remaining transition metals. That is because of in this 3D series, chromium and copper are pertaining to nearby half-filled and completely filled electronic configuration. That's the reason why chromium and copper slightly different electronic configuration will be provided, so that these two complex compounds are chosen for the calculation of spin-only magnetic moment values. Let's go with how to solve this. And for these two compounds, 3.87 will corresponds to chromium hexamine compound cation, and the second copper hexafluoride anion compound is having 2.84. So this will be the right answer. Let's see how it is possible to solve. In order to solve that, number of unpaired electrons in the chromium hexachromium plus 3 complex will be taken as 3. So because in a chromium compound, uh, uh, in the chromium compound, it is of atomic number 24. Electronic configuration is given as 4s1 3d5. Peculiar electronic configuration just now we discussed, so that we can write 4s1 5d 5 electronic configuration will be there for chromium metal. But here plus 3 oxidation state is provided. That's why 3 electrons can be removed. When 3 electrons removed, remaining 3 will be left in the valency shell. Total, this chromium hexacation complex is containing 3 odd electrons. Now, let's apply the spin-only magnetic moment formula, that is under root n into n plus 2. N related with its lone pair of electrons. Under root 3 into 3 plus 2 is the substituted value. So 3 plus 2 will be 5. 5 into 3, it will become 15. Root 15 is given with the 4 Bohr magnetons. 4 Bohr magnetons nothing but 3.87. So 3.90 almost 5. Sorry, 4.9 nothing but 5. So it will be cancelled out. 3.87 might be possible. 3.87 might be possible. So these two, either A or C, are possible with respect to chromium. Let's go with the copper calculation. Copper is the copper hexafluoro compound. It is the octahedral geometry. You can see here it is the weak field ligand and able to give the octahedral geometry, and the anion compound is there. And this copper, again, the system of copper is of atomic number 29. when you write its electronic configuration, 4s1, 3d10 will be there. 4s1, 3d10 is the electronic configuration. If you remove 3 electrons, being it is kind of -3, so that, sorry, so -3 is there here. What we have, -6 is there, so that it will be compensated. So copper will be attaining +3. The central copper is having visit of +3 oxidation state over here. So that +3 means 3 electrons should be removed. So total number of electrons are S1, D10 are there. Total 11 electrons are there. From 11 electrons, -3 electrons. 11 minus 3, it will become D8. So D8 distribution will be like this. So D8 distribution in this copper, being it is the weak field, so that we have to go with complete T2G orbitals filled with the 6 electrons, and the remaining 2 electrons will enter into higher level PG orbital, and these 2 odd electrons corresponding to spin only magnetic value. These 2 electrons we have to consider. So number of unpaired electrons in this copper hexafluoro complex will be 2. Let's apply the formula under root n into n plus 2, so that under root 2 into 2 plus 2. 2 plus 2, 4. 4 plus 2. Here under root 6 will come, and 2.44 magneton is the value over here. So 2.84 Bohr magnetons are provided in the option number A. The calculated spin-only magnetic moment of chromium hexaamino complex will be 3.87. Copper hexafluoride will be 2.84. For question number 4, option number 1 is the correct answer. Chromium pertaining 3 unpaired electrons, copper pertaining 2 unpaired electrons. 3 unpaired electrons corresponding to 2.87, 2 unpaired electrons corresponds to 2.84. By this, we completed question number 4. Let's move on to question number 5. A black colored element with the NS2NP1 outer electronic configuration cannot react with air in its crystalline form. However, amorphous form it gives an oxide in air which is acidic in nature. Identify the element. Here, from this data, it is obvious that NS2NP1 is the main group 3 element. Main group 3 element. The options provided are boron, aluminium, gallium, indium. All these belongs to main group 3 only. So that either of the option might be correct. But from this, we have to get black colored element. Okay. Aluminium is a metallic silver color. Gallium is also silver color. Indium is also silver color. But boron is having black color, right? So from this only we can find out which element it is. Crystalline form, if it is in crystalline form, it will not react with air. However, in the amorphous, means a random arrangement, boron reacts with air to give B2O3. This is called boron trioxide, right? So here, if you observe all the elements, boron is indicated with this, that is called a black color element. It is aluminium, it's a metallic aluminium. Everybody aware about aluminium foils and everything, which is the packaging device. And aircrafts also made up of lightweight metal, that is aluminium only. So that aluminium will be there, and the gallium. Gallium is another, is also exists in the silver color. Indium is also silver color metal. Thallium, if you observe, this is a somewhat dark color compound. This is not given in the options. Need not to consider, but these are the colors of the compounds. However, boron at amorphous condition will react with air. So in that, probably with oxygen upon heating conditions can be converted into B2O3. Boron trioxide formation is possible. The right answer will be option number 1. For question number 5, option number 1 is the correct answer. Let's move on to the last question of this session. The element that does not show catenation. Catenation is the property extension of the covalent bonds with the same element is called a catenation property, right? Catenation means self-linking of atoms in order to extend their chain. Chain length will be propagated by extending their covalent bonds with its own element. So which does not show the catenation. Options provided: carbon, germanium, tinine, lead. Carbon is the element with the exceptional catenation property in entire periodic table. Long range of carbon chains are able to given by this compound. That's the reason why carbon able to give the lot many number of compounds. Hence, organic chemistry is extensively studied because it able to give number of organic compounds. And the long chain polymers also generated because of its property called catenation, right? So that carbon will give catenation, germanium, tin, and lead. Let's see which is the correct answer. If you see the carbon, first what is catenation is given. Catenation is the linkage of atoms of the same element into the longer chains. If you see the carbon, its own elements can be linked either in the straight chain, branched, or the complex branch one, and cyclic form as well. All these are the typical examples of a carbon catenation property. Yes, it will give catenation. Go with the germanium. Germanium also is in the form of such a oligo-dimethyl. Okay, so here some extent of catenation you can see. Oligo means up to 20, less than 20 chain, atom chain is there, that is called oligopolymer. The, that extent of catenation property can be given by germanium. So we can see that germanium catenation property like this. And if you see the tin is also having that kind of self-interlinking, so that it is also the part of, here you can observe its molecular geometry as well. So this tin is also having that property of catenation. All are able to give except lead. Lead is not having this catenation property. Self-linking tendency, chain forming tendency is not provided. The right answer for this question, question number 6, last question of the session, will be lead. For question number 6, option number 4 is the correct answer. Lead is not able to give the catenation. Carbon is having long range of catenation property. Germanium, some extent oligopolymerization is possible. Tin is also having the tendency to catenate itself. Interlinking is possible, we saw just now. But lead is not having any provision to interlink with its own elements, right? By this, we completed the session. Hope it will be helpful for your preparation towards any entrance examination or competitive exam as well. So that I'm requesting you to kindly like, comment, share, and subscribe this channel. And thank you very much for your patient listening. And I hope this will be helpful. And we will go with the next new questions in the next session. Thank you. Thank you one and all for your attentive listening. Thank you.